Today we're going to talk about properties of logarithms. So, building off the last video, we know that the log function is what I like to call a what power function. So 3 to what power will give me 9? The answer will be 2. And we talked about one simple property, which is that log base b of b equals 1. Because b to the first power equals 1. B to the first power equals 1. So whenever these two expressions are the same, it equals 1. So now we're going to just build on that. We have something called the natural logarithm, which you will need to know. ln is what it's supposed to be, so if it looks like an E or something else, it's ln, it's just kind of cursive L's, that's how it's normally written, is equal to log base E. So E is a number. It's an irrational number, just kind of like pi, 2.718 something. And this is just kind of a rule that you'll need to remember. ln is equal to log base E. Just like when you have regular log, it's the same as log base 10. So now we're going to use this. Well, let's say we have ln of E. What is that? Well, if we rewrite this, we have log base E of E. And these two things are the same, which means the answer should be 1, because E to the first power equals 1. So ln of E just equals 1. So let's say I have 5,208,000 times ln of E. What should that answer be? It should just be this, 5,208,000. This equals 1. So I can interchange that with 1 whenever I need to. All right, so now let's talk about some of these other properties. So we have this one, the log base b of b. And we want to talk about some other ones. So just like exponents have product rules, exponent rules, and power rules, so do logarithms. So take a moment and write these down. So pause the video, write these down. We're going to practice them. We'll show examples of them on the next slide. So we have the product property, which is log base b of m plus log base b of n equals log base b of m times n. So we're just going to look at our formula. Notice our b is 6. This is a 6. Our m is 9. Our n is 4. So this is m. This is n. And these are b's. So we're given the left side. We want to make it look like the right side. But we know what b, m, and n are. So this just becomes log base 6 of 9 times 4, log base 6 of 36. Because 9 times 4 is 36. And this one we can actually solve. 6, or log base 6 of 36 is equal to 2. Because 6 to the second power equals 36. So the answer is 2 for the first problem. Second problem, again, we have the same base. Just a side note, if the bases are the same, are not the same, we can't do anything with this. This just stays just like that. It's not unsolvable, but we just can't combine them. We can't use this property. So over here, the bases are the same. The base here is E. You don't see it, but that's what the base is. And our m is 1 over 8. Our n is 6. So we just multiply. I put log we just multiply 1 over 8 times 6 over 1. And we multiply fractions, we multiply straight across. So we get ln of 6 over 8, which simplifies to ln of 3 over 4. This is not something we can solve without a calculator. If you want to put in the calculator, if Alex asks you to put in the calculator, feel free to do so. But this would just be left like this on one of my exams. So when we look at the quotient rule, which is just subtraction, so log base b of m minus log base b of n equals log base b of m divided by n. So when we add, we multiply. When we divide, when we subtract, we divide. So similar to the product and quotient properties with exponents. So this first problem, we have log of 1,000 minus log of 10. Remember, when you do not see a base, the base can be assumed to be 10. But our b is 10. We just don't see it. This is our m. This is our n. So we're just going to plug in the b and the m and the n on into this. So it becomes log base b of 1,000 over 10, which becomes, and I don't know why I put the b there, but log of 1,000 divided by 10, these zeros just cancel out, 100. And log of 100, because there are 2 zeros and the base is 10, is 2. So the answer should be 2. And we also could have done this another way just to kind of check. So log base 10 of 1,000 is just 3, because 10 to the third power equals 1,000. And then log base 10 of 10 is just 1, because 10 to the first power equals 1. So 3 minus 1 equals 2. So you can evaluate it either way, or you can prove this case by doing this, but you should still get the same answer. All right, and then the second problem, our m is 21 here, our n is 9. I mean, our n is 7, and our base is 9 for both problems. Again, if the bases are not the same, can't do anything with it, or I can't use any property. So this becomes log base 9 of 21 over 7, which is log base 9 of 3. And if you recall back to the rational exponents, 9 to the 1/2 power equals the square root of 9, which is 3. So this is asking 9 to what power? I should have wrote the arrow this way. 9 to what power will give us 3? And the answer is 1/2. So the answer for the second problem, log base 9 of 29 minus log base 9 of 7 is equal to 1/2. And the last property we're going to talk about with logarithms is the power property. And this one is extremely useful, or it will be extremely useful in the solving of equations that you guys are going to do in a couple weeks, maybe next week. So make sure you know this one. You know all of them, but this one is something that will come up again and again. So if we look at the first problem, we have log base 2 of 16 to the 4th power. And so, again, this is our b, this is our m, this is our n. So we're just going to rewrite it how we see it on this side. So n is 4, and then everything else pretty much stays the same. So now we have 4 times, well, log base 2 of 16 is asking 2 to what power equals 16? 2 to the 4th power equals 16. So this is just 4 times 4, right? Now let's say you saw this problem and you wanted to evaluate this exponent first. Well, we can do that too. And you would get log base 2 of 65,536. And we want to know with this problem, 2 to what power will give us 65,536? The answer should be 16. But that would most likely involve a lot of guessing and checking, because most people don't know 16. So you would just be trying all these numbers. Whereas in this problem, this is simpler. We know 2 to the 4th is 16, and then we just multiply that times this number in front. So that's one way to do it. And then here we have ln, or log base e, but the ln is natural logarithm of e raised to the 8th power. So this is our b is still e, even though you can't see it. This is our m, this is our n. So we have 8 times ln of e. So basically that power, whatever it is just coming to the front and multiplying. So ln of e is the same as log base e of e. These bases are the same, which means the answer should be 1, or this quantity should equal 1. So this is 8 times 1, which is just 8. So the last thing we're going to talk about is this change of base formula. This is also extremely important because this will help you solve any logarithm. So if we look at example 1, well, first the formula log base b of a is equal to the log of a divided by the log of b. Notice here there is no log, so the base is 10 for both of these. At example 1, we have log base 9 of 83. So this is asking us 9 to what power will give us 83? Well, 9 to the first power is 9. 9 to the second power is 81. And 9 to the third power is 729. So it's not 1, 2, or 3. But most likely it's between 2 and 3. It's probably a little bit higher than 2. But we don't want to guess. So we're going to put this in the calculator. And the way we do this, and you have a calculator on Alex, and we're going to show you that in the next video. So I'm going to go over some examples. We have log. This is my B. This is my A. In fact, let me do that in a different color. This is my B. This is my A. So log base 9 of 83 is the same thing as log of 83 divided by log of 9. And so when we put that in the calculator, we get approximately, because I'm sure it's going to be a decimal, we get 2.011 approximately. So it's a little bit more than 2. And the last one, so 3 to what power will give us 400? So we're going to put that in the calculator as well. Now you want to be careful about how you put things in the calculator. So this will be log of 400 divided by log of 3. So in the calculator, you should have log. When you press the log button, it's going to open the parentheses for you. Put in 400, make sure you close the parentheses, and then divide by log of 3. Close the parentheses. And you should get approximately 5.454. And so if round to whatever place Alex asks you to round to, but 3 to the 5.454 power should give you approximately 600. So if you put that in the calculator, you should get very close. So that's a way to check your work. All right, so watch the next video. So I'm done with this video. The next video will have examples from Alex for you guys to see me do.